Hello everyone, my name is Meraj Pathan, studying in B.Sc second year from Adarsh Education Society. Today we are discuss about first fundamental theorem on integral calculus. Now will see our theorem statement. If a function f is a bounded and integrable on closed interval a comma b, then function defined as f of x is equal to integrate f of t between the limit a to x is continuous on closed interval a comma b. And furthermore, f is a continuous at point c of a closed interval a comma b. Then f is a derivable at c and f dash of c is equal to f of c. Now we will see proof. Since f is bounded, therefore k is greater than 0 such that mod of f of x is less than equal to k for every x belongs to closed interval a comma b. If x1 and x2 be any two points of closed interval a comma b such that a is less than equal to x1 is less than equal to x2 less than equal b, f of x1 is equal to integrate f of t between the limit a to x1, and second function f of x2 is equal to integrate f of t between the limit a to x2. Now f of x minus f of 1 is equal to integrate f of t between the limit a to x1 minus integrate f of t between the limit a to x2, then is equal to integrate f of t between the limit x1 to x2. Therefore mod of x2 minus mod of x1 is equal to integrate f of t between the limit x1 to x2 is always less than k and x2 minus x1. Thus for given epsilon greater than 0, we see that mod of f of x2 minus f of x1 is less than epsilon if mod of x2 minus x1 is less than epsilon by k. Hence the function f is continuous. Let f is a continuous at 0 point c of a closed interval a comma b, so that for any epsilon is greater than 0 such that mod of f of x2 minus f of x1 is less than epsilon. For x minus c is less than del, let c minus del is less than s is always less than equal to c less than equal to t less than equal to c plus del. Therefore mod of f of t minus f of s divided by t minus of s, then minus of f of c is equal to mod of 1 by t minus s divided by integrate f of x between the limit s to t minus 1 by t minus of x integrate f of c between the limit s to 1 is equal to mod of 1 by t plus s integrate f of x between the limit s to t minus f of c is greater than 1 by t minus of s integrate mod of f of x minus f of c between the limits s to t is always greater than epsilon, then f of c f dash of c is equal to f of c. Hence the theorem is proved. Thank you for watching this video.